There are recent reports from the members of public that there's an odour present in the Kallang monsoon drain, and this odour is causing a lot of discomfort for the residents living here. Hence, they are trying to find out the root of this problem. They mainly think that it's from Eco-Friendly Private Limited, and it is known that they would throw their water waste into this drain at about 6 PM every evening. So let's hear and see what they are doing. Hello, sir. What are you intending to do with all these bottles?
We're actually collecting some water samples from the canal, actually.
What are you expecting to find in that water sample you have collected?
Because we suspected there's a presence of transition metals that's affecting the color and the smell of the river.
Oh, thank you, sir.
Yeah.
So this is what's happening in the Kallang monsoon drain. Hence, let's see what the officials are planning to do. Thank you. Over and out.
Hey Bruce.
Okay, they're at it again. You know what? Never mind. I'm just gonna look up Keisha. She said she was gonna find out more about these transition metals. There you go. This is the water sample. That's what I got.
Now we're talking about transition metals. What is transition metals? Transition metals characteristically have incompletely filled d subshells or readily give rise to ions with incompletely filled d subshells, often known as d block elements. Next, I'll be talking about the physical properties. Firstly, atomic and ionic radii. Atomic and ionic radii of the first row of transition metals are much smaller than those of calcium due to the greater nuclear charge and poor shielding effect by the 3d electrons. Across the first row of transition elements, the atomic and ionic radii are relatively invariant. As we go across the group, there's an increase in nuclear charge due to the increase in proton number. However, the increasing nuclear charge is countered by the increasing shielding effect due to the increasing number of inner shell electrons. Hence, atomic and ionic radii are relatively invariant. Secondly, we'll be talking about the first ionization energy. First ionization energy of the first row of transition elements are much higher than those of calcium due to the greater nuclear charge, smaller atomic radius, and the poor shielding by 3d electrons. The first ionization of the first row of transition elements involves a removal of an electron from the 4s orbital. Across the first row of transition elements, the effect of increasing nuclear charge is countered by the increasing shielding effect due to the increasing number of inner shell electrons. Hence, the first ionization energy remains relatively constant. Thirdly, melting and boiling point. First row transition elements have much higher melting point than that of S-block metals, example calcium. They have high melting point, usually more than 1000 degrees Celsius, and boiling point usually more than 2000 degrees Celsius. In S-block elements, only the outermost 1 or 2 valence electron per atom are available for metallic bonding, whereas in the first row transition elements, both the 4s and 3d electrons are available for metallic bonding due to the small energy difference between the orbitals. Therefore, the transition elements have greater number of valence electrons available for metallic bonding. In addition, metallic bonding in the transition elements are stronger because of the ions of the first row of transition metals having smaller radii and higher charge than S-block ions like K+ and Ca2-. Hence, more energy is required to overcome the stronger metallic bonding in the transition elements. From Sc to V, the melting and boiling point increases due to the increase in number of unpaired electrons that are involved in metallic bonding. Mn has a relatively low melting and boiling point due to the half-filled d subshell and the 3d electrons that are less available for delocalization, which results in weaker metallic bond. It has the same effect for Cr due to the low nuclear charge. From Fe to Zn, the melting and boiling point generally decreases as electrons begin to pair up in the 3d orbitals. The paired electrons do not participate fully in the metallic bonding, hence decreasing the strength of the metallic bond. Next, we'll be talking about density. First row of transition elements have much higher density than calcium. Density depends on the combination of factors including atomic mass, atomic radius, and the arrangement of particles in the crystal lattice. Transition elements have smaller atomic radii and closely packed structure as compared to larger atomic radii and low packing S block metals. Gradual increase in density from Cr to Cu is due to the increase in relative atomic mass while atomic radii remains relatively constant.
Now, let's move on to the chemical properties of transition elements. There are mainly 6 of them, so let's have a look. The first one being their variable oxidation states, which is different from other elements which have a fixed oxidation state. In TMs, variable number of electrons from the 3d and 4s orbitals can be involved in bonding as 3d and 4s orbitals have similar energies. While in other compounds, they lose a fixed number of electrons from their outermost shell since the removal of the next electron from the inner quantum shell requires much higher ionization energy. Their second chemical property is their ability to form complex ions. A complex ion consists of a central metal atom or ion surrounded by a number or cluster of anions or neutral molecules called ligands via the formation of dative bonds. In this case, let's assume that the Toy Story aliens are ligands. A ligand is an anion or a molecule that has at least one lone pair of electrons to form dative bonds. So in this case, the arms of the aliens act as the lone pair of electrons and the cupcake acts as the central metal ion. For a real-life scenario, let's pretend that the cupcake is Fe, the central metal atom, and all the Toy Story aliens are acting as the ligands. This compound would have an octahedral shape, have a coordination number of 6, and the oxidation number of the central metal ion would be -3. But why are these transition metals so special? Why do they do this? Transition metals form high charge density cations to attract lone pairs of electrons from ligands, which favor dative covalent bond formation. And the presence of energetically accessible vacant orbitals in the central metal ion help to accept lone pairs of electrons from ligands. Now let's talk about colors. So when we're talking about colors, we have to think about the electromagnetic spectrum. The electromagnetic spectrum is a lineup of all the waves in the world according to their wavelengths. So let's have a look at the electromagnetic spectrum. Okay, this is it. On the right, there are gamma rays. And on the left, there are radio waves. The brightly colored section at the top is the visible light section. It's a very small section. The blue side is closer to 400 nanometers and the red side is closer to 700 nanometers. The whole thing is considered visible light, denoted by the sun. Yay! Gamma rays have a lower wavelength, while radio waves have a higher wavelength. Just remember that for later when we're using the formula. So now, getting back to the point, why are complexes colored? There are a few parts to this explanation, so bear with me. Okay, in TE, the 3D orbitals are all degenerate, which means that they're all of the same energy. Keep this in mind when I'm talking about this next part. In the formation of an octahedral complex, the 6 ligands approach the metal ion. As they do so, their lone pairs repel electrons in the 5d orbitals, causing the 5d orbitals to increase in energy. This causes the 5 3d orbitals to split into 2 groups of orbitals, one group of 2 and one group of 3. For most transition metal complexes, the energy gap is relatively small and corresponds to the visible light region of the electromagnetic spectrum. So let's see what happens to the electrons during splitting. When white light is shone, the electrons are excited. But what happens when the electrons are promoted? Well, the 3d electron at the lower energy level will be promoted to a higher energy 3d orbital. This is called DD transition. the energy gap is in the green and yellow range, the green and yellow colors are absorbed, and the red, orange, blue, and violet lights are transmitted. The color in the solution is then purple, since purple is the complementary of the colors absorbed. Now, since we know why they are colored, let's find out how to identify their colors. To do this, we need to talk about complementary colors. The observed color of an object is the result of wavelengths of light that are not absorbed and therefore reflected off the object and into our eyes. This is called the complementary color. Complementary colors are shown on opposite sides, and the approximate wavelength range for each color is indicated. For example, if a complex absorbs red light at a wavelength of 720 nanometers, it will be seen as green in color. Let's talk about the factors affecting the complex colors. The energy gap is denoted with the formula Hc over lambda. Increase the energy, you reduce the lambda, and the solution will appear red. Decrease the energy and you increase the lambda, and the solution will appear blue. We have now come to its magnetic properties. An electron possesses a spin that gives it a magnetic moment. When all the electrons in an atom are paired, the magnetic moments of the electrons effectively cancel each other out. The substance is then known as diamagnetic. Diamagnetic substances are those that are slightly repelled by a magnet. When an atom or an ion possesses one or more unpaired electrons, the substance is known to be paramagnetic. The magnetic moments on an individual ion are randomly orientated. When placed in a magnetic field, the magnetic moments become aligned and roughly parallel and produce a net attractive interaction with a magnet. Thus, paramagnetic substances are those that are attracted by a magnet. Ferromagnetism is the strongest form of magnetism amongst all. Ferromagnetism arises when the unpaired electrons of the atom or ions in a solid are influenced by the orientations of the electrons of their neighbors. The most stable arrangement results when the spin of electrons on adjacent atoms or ions are aligned in the same direction. Now we're going to talk about the catalytic activity of these complexes. In the following example, we're talking about the reaction between iodine and thiosulfate. Iodine and thiosulfate in this reaction represent the angry woman and the man. But when the angry woman and angry man are together, they will not be able to get married because they have problems. So they need help. But where do they get this help? Of course, they have to go and get psych help. But in this case, we're talking about a catalyst. The ability of transition elements to vary the oxidation state and the availability of partially filled D subshells allow it to be a very good catalyst. Step 1. The angry woman seeks psych help, and in the end, the psych help helps her and she becomes happy again. The Fe2+ reacts with the thiosulfate for it to become Fe3+ and a sulfate ion.
In this expression, I- reacts with Fe3+ to become iodine and Fe2+.
So, for the overall step, you put the angry couple together, you catalyze the reaction with psych help, and you get the desired product. Now we have come to heterogeneous catalysis. The catalyst used provides the surface in which adsorption by the reactant molecule takes place. Transition elements provide the suitable anti-orbital, and the lone pairs of electrons in 3d, 4s and 4p subshells form coordinate bonds with it. When this happens, the bonds between reactants become weaker, and this enables the products to be formed easily. Let's move on to toxicology. Chromium can affect the body in 3 different ways. The skin, through chrome ulcerations and chromate dermatitis, which both cause irritation in the skin. It can affect the respiratory system. It causes sneezing, nasal septum ulceration, and perforation. It also increases the risk of lung cancer. It can affect the liver too, as it causes liver damage, but this is rare. It can be found in our meat, potatoes, and vegetables. Iron is also essential in hemoglobin, the red coloring agent in blood that transports our oxygen throughout our body. However, the chronic inhalation of excessive concentrations of iron dioxide might enhance the risk of lung cancer. And some iron compounds are especially hazardous to the environment and if found, should be removed immediately. Copper is very toxic because excessive free copper impairs zinc homeostasis and vice versa, which in turn impairs antioxidant enzyme function, increasing oxidative stress. Therefore, chronically elevated levels of copper intake produces zinc deficiency.
A possible analytical method that can be used to identify and measure the amount of trace metal is atomic absorption spectrometry. Atomic absorption spectrometry (AAS) is an analytical technique that measures the concentration of an element. It can be used to analyze the concentration of over 62 different metals in a solution. The technique made use of the wavelength of light specifically absorbed by an element. Atoms of different elements absorb different characteristics of wavelength of light. The atoms correspond to the energy needed to promote electrons from one energy level to another higher energy level. For example, with lead, a lamp containing lead emits light from excited lead atoms that produce the right mix of wavelength to be absorbed by any lead atoms from the sample. In AAS, the sample is atomized. A beam of electromagnetic radiation emitted from the excited lead atom passes through the vaporized sample. Some of the radiation is absorbed by the lead atoms in the sample.
Thank you for watching. I hope you all learned something today. Over and out. 2 weeks later on Channel 5.
Good morning, representatives of Eco-Friendly Private Limited, reporters and the members of public. We are here to discuss the issue on water disposal in our Kallang Monsoon Drain. There are complaints filed by residents that the smell caused by the water pollution is interrupting with their daily lives. Now, I'll first talk about the offence they have committed. Under the requirements for discharge of trade effluents into the public sewers, the maximum concentration of chromium and copper allowed to be released is 5 mg per litre and iron is 50 mg per litre. None of the amount of trade effluent released had exceed the maximum concentration allowed. However, due to the amount and type of water waste released, it became a nuisance with its odour, which violates the regulation. In the regulation, any substance that either by itself or in combination or by reaction with other waste or refuse may rise to any gas, film, odour or substance which is or likely to be a hazard to human life, a public nuisance, injurious or otherwise objectionable, or which prevents or is likely to prevent entry into the public sewer by workmen maintaining or repairing is not allowed to be discharged into a drain. Any person who is guilty is liable to have a fine not exceeding $50,000 and or imprisonment for a term not exceeding 12 months for the first conviction. For the second conviction, the guilty is liable to a fine not exceeding $100,000 and or imprisonment for a term not exceeding 3 months. Those continuous offenders will have a further fine not exceeding $2,000 every day during which the offence continues after conviction. This regulation is placed to reduce the environmental pollution which can potentially affect people or animal in health or can threaten to pollute any inland water. Hence, it is important to comply to this regulation. Now, I'll pass my time to the managers of Eco-Friendly Private Limited to talk about how they would want to resolve this issue.
So I would like to once again thank the Pollution Control Officer from the PCD for the stern reminder. Once again, on behalf of the whole company, I and my colleague, we would actually like to apologize to the members of the public, the reporters and NEA and the officers for failing to comply to NEA's strict regulation. We do not take this situation very lightly and are looking into various and multiple ways to overcome this issue. We have looked into various and multiple wastewater treatment technology available commercially, and we actually wanted to share some of these ideas to the officers, reporters and the members of the public and the people of Singapore. So after a long discussion, we actually have came across a couple, and we'd like to share our first idea that we suggested was chemical precipitation, with the help from our EHS department, or Environmental Health and Safety, and the help of our higher ups and managers. So what this essentially is that the aim of precipitation is to precipitate the chemicals or your heavy metals from your wastewater by forming an insoluble substance or compound which can be separated from the water, so it can be safe to be disposed into your canals. So the whole process can actually be represented by this equation, and the metals which is represented by M2 plus will actually be reacted with your caustic, usually your hydroxide, and this will form your metal hydroxide particles. So again, the whole process itself of the wastewater from different departments such as your manufacturing, etc., will actually first enter your rapid mix. So the goal of rapid mixing is to actually increase the pH of your wastewater, so to form our metal hydroxide particle, was mentioned earlier. So coagulants such as organic polymers is added directly into the wastewater. So the purpose of these polymers is to attach to the metal solid particles. The small metal hydroxide particle that has embedded and has binded with the polymer will actually cause the metal hydroxide particle to increase its size, and which promotes settling. So once this whole process is done, it actually makes its way to the sedimentation basin. So the flow within the basin itself is a lot more common compared to the rapid mix. So which also enables it to, which also further allows and promotes sedimentation and settling. Apologies. So this is because as the particles are much heavier than water, the whole process could occur in the sedimentation tank. However, there's a small reminder: the pH during sedimentation must be maintained at approximately 9 pH to ensure that none of the metal hydroxide redissolve and become soluble in the water. And the detention time for this whole process is about 1.5 to 3 hours before to allow adequate settling. So once this whole process is done, the effluent will again make its way to the filtration unit. So in here, simple as the name applies, it will filtrate your fine metal hydroxide particle that wasn't able to settle down, maybe because they were too fine or they were too light. So water is passed through silica sand to capture the remaining metal hydroxide particles. So in this filtration unit, filtration completes the whole process and the metal treatment process. Only now should the pH level should be lowered, and should it be safe enough to be discharged into our wastewater and canals. So some of the effectiveness of chemical precipitation are that precipitation has a high yield, it has a high degree of selectivity, specific compounds can be removed, waste materials obtained can actually be reused. The sludge, such as your metal hydroxide, can actually be used as your reagents. It's inexpensive, so not a lot of money will be going into the system, and the whole process can be automated. So again, I would like to pass my time to my assistant, Weewen, and he'll talk more about the different methods of water treatment.
Okay, so I'm going to thank Manager Ideal. Now, as part of Eco-Friendly Private Limited, it is our utmost duty to provide effective wastewater treatment methods to minimize pollution. Our company takes full responsibility for any incidents of pollution and being unable to comply with the regulations set by the National Environment Agency. That being said, we have agreed to use a handful of methods we found effective for wastewater treatment. Firstly, rapid sand filtration is a physical method of wastewater treatment in which large particles are filtered using sand filters. Basically, wastewater flows to the top of the filters, consisting of layers of sand and gravel at a height of 1.5 to 2 meters. Iron, chromium, and copper particles accumulate between the spaces of sand particles, reducing concentration of metals in the wastewater. Smaller particles are accumulated as well due to adhesion between sand particles and the pollutants. Rapid sand filtration is also effective in reducing turbidity, as filtration of suspended particles reduces cloudiness in water. Now, aeration is another effective method of wastewater treatment, which utilizes oxygen from air to oxidize metals dissolved in the wastewater. Dissolved metals in wastewater, especially iron, are unfilterable during filtration. Now, aeration oxidizes these metals to form solid compounds which are filterable. Iron, for example, occurs in wastewater in the form of ferrous bicarbonate. During aeration, ferrous bicarbonate combines with oxygen and water to form ferric hydroxide and carbon dioxide. Ferric hydroxide, however, is insoluble in water and thus easily filtered using filtration. Any method of adding oxygen to water can be considered a method of aeration. And methods of aeration include using waterfalls, fountains, or jet aerators. So after discussion, we concluded that aeration and chemical precipitation are the most effective methods of reducing concentration of metals in wastewater. Once again, we would like to apologize for this incident and we hope that such an incident will no longer happen to the residents. On the other hand, we would like to thank the manager of Eco-Friendly Private Limited for assisting us with this incident. I will now pass the time to the manager Aidil to talk about the implementation of these wastewater treatment methods.
Thank you, Ewan. So again, just to add things on from what my assistant just mentioned. So not only did we just choose the different and various technology to deal with heavy metals, but don't be assured that this technology are well on its way and we are implementing it in our system and our wastewater treatment facilities, possibly by the end of the year. And hopefully this incident will never happen again, and we'd like to apologize once again to the members of the community, to the public, obviously NEA, to the pollution officers. And thank you once again for tuning in, and good night.